So I wanted to talk about revisiting quantum economics. I had given a talk many years ago on quantum economics at the Rama conference. That is a long time ago. Things have slightly, the situation has changed. Therefore, I thought I'd revisit that. I want to just, after a general introduction, go through with the background for mathematical economics and how it developed, Lagrangian economics, Hamiltonian economics, and the problems of neoclassical economics. Then I'll be talking about my suggestion with quantum economics, and then what others have done on quantum economics. And finally, my suggestion with quantum uncertainty, and then a conclusion after that, which is mentioned here. Let me say, in my opinion, when one applies mathematics to any field, it is essential to actually understand that field to which you are applying. Not simply to go ahead and say, okay, I've got the tool, I'll provide you with the use of the tool. It depends on the subject as to how it's to be used. It won't make sense otherwise. And too many people just do the routine type work. Somebody else, if there's a problem, they go through a calculation. I'm seeing a quotation by somebody that when somebody was arguing about economics, the answer was, shut up and calculate. You don't think just calculate. I'm saying the opposite. Calculation is only meaningful if you think. So the background, I had written a paper on quantum economics in 1978, which was duly ignored for 40 years. Because I published it in the Pakistan Economic and Social Review. And then nobody ever looks at Pakistan Economic and Social Review. It's only to publish it. I didn't know it at the time. There have been papers with both words, quantum and economics, in their titles before mine. But they seem to have been based on ignorance of economics or quantum theory or both. Much later, 1994, there was work that talked of genuinely quantum behavior in the social sciences. Now in 2024, a new journal, Quantum Economics and Finance, has been launched from Columbia University, USA, and that's the new development because of which I wanted to revisit. Early attempts at a formal analysis of how wealth grows, which forms the basis of capitalism, appeared in Adam Smith's The Wealth of Nations, 1776. It was later followed by Karl Marx's Das Kapital, published in 1867, in 91 years, which is the basis, of course, of communism. The first mathematical model for the economy was formulated by Alfred Marshall, but the first publication is by Leon Wallace in 1874, and I won't try to read the French. The publication by Alfred Marshall, the Principles of Economics, is in 1890. John Maynard Keynes used mathematics to explain how the market works in the general theory of employment, interest, and money, which was published in 1936. More powerful methods of the calculus of variation came from John von Neumann, and that is 1928 there, which is before the general theory of employment, interest, and money. But that was the book. Keynes had been talking about that work earlier. Marshall stated the law of supply and demand. Supply equals demand. Wallace formulated the requirement that there should be no excess demand, because otherwise the producer of the commodity would always find it worthwhile to produce more, so that if there's excess supply, simply it would be wasted. You have to therefore get a balance. The use of the calculus in economics here resembles what is done in mechanics in working out static problems. D'Alembert's principle, where you say that the effect of the force must balance the force applied so that there is no net change, so it's static. That's exactly the same thing between them here in economics. You see, the thread of mathematics goes through. It's not that there is actual physics causing anything in economics or vice versa. But it's the mathematical formalism can often be the same. To obtain maximum benefit for minimum money cost, constrained optimization using Lagrange multipliers was applied in economics. The quantity to be minimized is the quantity of the commodity Qi, and to be maximized is the price Pi. This is the claim by Smith that the rational man maximizes his profits. So that has to get maximized. Keynes assumed a perfect market, infinitely many consumers, infinitely many producers are supplying infinitely many commodities, and yet you have instantaneous information about the whole market. He claimed that the market forces of supply and demand would reach optimality without intervention by policymakers. Therefore, the neoclassical laissez-faire doctrine, leave it alone. Let it run itself. Johann von Neumann was a mathematician who developed ring theory, a physicist who worked on quantum mechanics in shock waves, was the father of cybernetics, who made the first programmable computer. And for our purposes here, an economist who not only developed game theory in which responses to different possible actions lead to the formulation of different strategies, but also developed the general equilibrium model for production of commodities, which is an input-output model. From the 1950s, economic modeling was heavily influenced by physics, but ignored the development of field theory by Faraday and Maxwell in the 1850s and 1860s. It followed the Newtonian mechanical reasoning. That has rigidity in it, in the way of thinking. And so the neoclassical all inherited that rigidity. I will not go into too much detail about the field theory, but the point is, in Newtonian theory, there's a cause and an effect, each time one and then one. In field theory, the whole previous base is the cause for the whole future. It's not one to one. all that there was before, you allow it to evolve a little, is what is responsible for all that there is afterwards. No single cause to any single effect. All the effects are there with all the causes before interacting, and so that is the way it would work. You can see that for economic purposes, that's going to be far more relevant, the field theoretically, rather than the strict cause and effect, one cause, one effect. For social purposes, there isn't one cause, there isn't one effect. So, to obtain the optimal policy, the ground in Hamilton's mathematics was involved. The cost is called the objective function, and so corresponds to the Lagrangian L, which is to be minimized. This will be a function of Qi, the quantity of the commodity consumed, and its time derivative, dqi by dt, Q dot I. Now, in mechanics, the rate of change of position makes good physical sense. It's the speed, velocity. The time rate of change of the commodity consumed does not make good economic sense. It doesn't have economic significance by itself. There's no relevance for that. To proceed, let me consider the linear optimization problem of minimizing a linear objective function subject to a constraint. The economic motivation is arrived at as follows. If K1 and L1 of commodity C1 give as much satisfaction as K2 and L2 of C2, so C1, C2, and you do K1, K2, or L1, L2. So K1, L1, and K2, L2, they will be the same. Sorry, I've done K1, L1 again, K2, L2 the second time. The curve of all pairs, so K1, L1, K2, L2, etc., will give you what is called an indifference curve. For N commodities, this is extended to indifference hypersurfaces. Satisfaction is to be maximized within the budget. This is called the budget constraint, given by the hyperplane Qi dot Pi equal to Q dot P equal to D, where D is the total budget, the money available. The price is Pi, and where I have here used the notation Qi, Pi, the I repeated means I sum over all I. So it's Q1, P1 plus Q2, P2, etc. The amount of satisfaction then, in some sense, is measured as a utility function. Let me stress over here, and then it is maximized subject to the above budget constraint. Here there had been a debate between von Neumann and Morgenstern about whether utility should be cardinal or ordinal. Is it only this is preferred to this is preferred to this, and you can't say it's preferred as twice as much or 3 times as much. What was done was using the ordinal, the cardinal value, so that you can do that. This is an assumption. There's no further basis to which one goes ahead with that. The dual problem to this is to minimize the cost, C, Qi, Pi, subject to the same budget constraint. The hyperplanes Q dot P equal to C can be then moved parallelly to increase C till you get to the budget. Go on till you touch it. So that this will be the tangent then to the hypersurface. and that will be very important. Different groups of similar commodities are needed at times between which no indifference is possible. As an example, shelter and food, you can't replace one by the other, you need both. So this is, whereas as opposed to Coke and 7-Up, you could interchange, but you can't do something like shelter and food. So B must be replaced by BA, a whole set of budget constraints. For this thing, this type of thing so much, this type of thing so much, you first split your total money into those sub-budgets and then you go. This process can be written in terms of the Lagrangian by putting in the Lagrange multipliers into QA minus BA, so that will give you the budget constraint there. And then the objective function is FQA, the original one. And so now this will be the Lagrangian function that has to be minimized. Kuhn and Tucker they generalized to non-linear objective functions instead of the example I gave, linear example. Now non-linear objective functions and constraints. Again, not a linear budget, but non-linear. Then you have the theorem, either the constraint is slack, lambda A equal to 0, which means that that constraint doesn't apply, you will not bother with the constraint. And the optimal is then in the interior. Or they are told lambda A not equal to 0, then it has to be on the boundary. So it could be on the interior in part and on the boundary in part. And that is the critical theorem. It is on the corresponding part of the boundary that you will have the optimal value. Now, Hamiltonian mechanics have been developed differently. The multipliers clearly have to have some economic significance when you do that, for taught constraints when they apply, where a value is even obtained for them, but it is not clear what the value is. This becomes clear in the Hamiltonian formalism. The Hamiltonian is defined in terms of the Lagrangian by saying H equal to Q dot P minus F, the Lagrangian. The action is the time integral of the Lagrange density. Here, the total money spent over time becomes the analog of the action and is minimized. The requirement of minimization yields the Hamilton canonical equations to get a dynamical economy. This is a time evolution. So dH by dQA equal to minus dPA by dt, and dH by dPA equal to dQA by dt. So you have to go on producing at this rate the commodity, the derivative of the Hamiltonian with respect to the corresponding P. It is assumed that an economy continually growing with time is desirable and desired. Should it be? I'll come back to that. It's taken as granted, it was obviously, but I'd like to come back to that. Recall that in Newtonian mechanics, P equal to M dot, where M is a constant for the mass that measures the inertia of an object. However, in field theory, in physics even, there are no such relationships. There, the natural formalism is Hamiltonian. In economics, again, Q dot didn't have economic significance that way until we come to it from the other method. And then this is again the same thing, so the Hamiltonian formalism seems more appropriate. In this formalism, the Poisson bracket defined in this way is used. Price change is related to change in the quantity of the commodity consumed through supply and demand laws, but not the time rate of change, and certainly not the second time rate of change of the Lagrangian formalism. The Hamiltonian analog of the momentum is price. Large multipliers for taut constraints will yield prices. The cost of satisfying the constraint is called the opportunity cost. So it makes very good sense in economics that where you are foregoing something that will cost you, or you're getting something because of violating or hitting the constraint, then there you're going to have an opportunity cost associated. The above formalism yields the Hamilton equation, which I've given here. There is A is a canonical function, the Hamiltonian is a canonical function, then the Hamiltonian Poisson bracket with A is dA by dt. For any canonical quantity A, the action function is given this way. A of P and Q is given here. We can then minimize the total cost over time, or maximize activity. Let me say here, in physics, what we hear is being called cost or price, in there is energy. Money is corresponding to energy. That's the connection for that purpose. It's negative, the total profit over time, for a finite time horizon, 0 to t there, so the t is the time horizon, is by the appropriate choice of objective function. So, people had various problems with the more mathematical developments in economic theory. Adam Smith said, a rational man, not a woman, a rational man maximizes his profit. This was not an observation of pre-existing laws of human behavior, but a statement that caused humans to behave in a certain way. It's the statement of the law that has brought about the law and not the other way around. In physics, you observe something and extract from there the law. It says an observation, this is the same everywhere, and you come to a conclusion from there. But here, my argument directly, before it was stated, Americans gave their lives happily for God and country, in the king country. Afterwards, they were happy to sell their grandmothers for God. Because, after all, people want to be seen to be rational. It's a self-fulfilling prophecy. The self-fulfilling prophecy again came with Karl Marx's superb critique of capitalist economics in Das Kapital. Beautiful critique, worth reading. Anybody who hasn't read Das Kapital, volume 1, the part 1 is a critique of capitalist economics, and it's absolutely superb. He noted a lot of inconsistencies, and then he decided the inconsistencies arise because you use exchange value. The value for anything is what you get in the market, and it should be replaced by an enforced labor value. What is labor value? How do you measure labor value? Exactly that same type of critical analysis was needed, which Marx used for capitalism. It was needed for the Marxist suggestion of labor value. It was not used. There was no such analysis done. How do you actually go about defining for labor value? Is it consistent or does it have built-in inconsistencies? The answer is it has built-in inconsistencies. Inevitably it will, because you're putting it in by hand, whereas what Adam Smith had said is this comes automatically, so you don't have to put in anything, you get to identify it from observation thereafter. But here you're saying labor value should be the amount of labor put in. But if an unskilled laborer could be put in or skilled laborer, if you're going to give equal rewards, nobody will get skilled. You need skilled labor. So now what will you do? You need highly skilled or trained labor, highly educated, and you won't have that. You don't get the same, so it can't be done that way. Marx did a quick fix. He said, we will have labor value with the amount of labor put in, but modified by how much time you put into. And how much time is not simply a matter of time and effort. How do I measure that effort? It is not measurable. So that is where it went wrong. The claim was that the worker is alienated from his work by the exchange value, but gets his due share with labor value. And this resolves all problems. Immediately, all solved. Karl Marx and Friedrich Engels then predicted that in an industrializing society, it was actually, England was the base for Marx's analysis. He was sitting there in England and working through, seeing what was happening, and that was the base on which he had come to the conclusion. In an industrializing society, there will be a spontaneous revolution, a workers' revolution that will occur. It will not, according to them, occur till it's an industrializing society. It will not happen in a feudal society. Vladimir Lenin used this, for people who don't understand anything of what was being talked about, to tell them this, and he wrote about what he called a Marxian revolution in the feudal society of Russia. The only feudal society, not industrializing, and it was brought in, and regardless of the fact that Marx said this will not happen, it happened because Lenin said that Marx had said this would happen. All that mattered was what the revolting people believed. It's a matter of belief, not a matter of something in itself. That part was being ignored by everybody. Now I admit that I do not fit Smith's idea of rationality. If someone states a law of how I will behave, I will probably behave differently. I don't want to be seen to be predictable that way and one say, okay, you say everybody eats 3 meals a day, I don't. I eat 2 meals a day. The prediction will not necessarily be correct. I will react one way. Somebody else may go exactly along with what everybody is saying. Well, everybody will eat 3 meals a day, then all reasonable people eat 3 meals a day. Then somebody who's eating 4 meals a day says, I better cut down 3 meals a day. Now, while an electron does not care what laws are stated about it, people do. Economic laws are very different from those of the natural sciences because of self-awareness. simply applying the natural science laws in the same way, you are ignoring the, the, the self-consciousness, if I may say so, consciousness of oneself. Keynes assumed perfect competition, and that has problems. There are not infinitely many consumers and producers, and the more that there are, the longer it takes for any to get any information about the imperfection. The market cannot be perfect. These market imperfections were supposed to be responsible for the poor performance of the theory. But many blame the mathematics used rather than the market imperfections and argue that the mathematical way should be avoided. Naved Hamid used to be one, I don't know if he still is. Maybe because economists don't want to avoid mathematics. Labor theory assumes that people would minimize their work effort to get the same earning. The transitivity problem of utility analysis, which is that I can prefer A to B to C, and Bedesad prefers B to C to A, and Shayad prefers C to A to B, then for the three of us, A is preferred to B, is preferred to C, is preferred to A. Non-transitive. And we need transitivity. This is the narrow impossibility theorem. You can't construct a social welfare function based on this. So that will be a problem. One can try to sidestep these problems or follow the other strategy, as John Wheeler advised in his physics, face them four squares, he called it. Start trying to look at the problems to deal with them. That's what Jan Tinbergen did with labor. Rather than just trying to sidestep it, he tried to incorporate it. Indifference analysis assumes that all consumers always know the value of QA desired and PA that they are ready to pay for it. Can you tell me, Shahid, how much you would be ready to pay for Coke or 7-Up, and how much of which would you want?
Oh.
Right now, if I ask off the top of the head, no. You need to think about it. It won't be there in your mind all the time. You will first have to think, you have to be asked the question. Okay, but then if you have to be asked the question, it will be determined when the question is posed. It won't be determined before. Anybody who studied quantum mechanics knows that's exactly what we done. We follow the same logic. It isn't the sphere is known, you will determine the quantities. So that is important. Let me say, for example, here, I may not be feeling like having, let's say, 4 or 7-Up at the moment. So I say I pay virtually no price. Now, put me out in the sun for 5 or 6 hours, and I'll have a very different answer. It will depend on that, but it could also depend on what the price I'm told is. Now, of course, if that is the case, the result would depend on whether I was first told the price and then asked how much I wanted, or first asked how much I wanted and then told the price. There will be a difference. This is obvious. This is how advertising works. I'm made to believe that something is desirable, so I want it, and then told the price is only so much. That's what gets me in to buy things. This is different for different people and depends on the object. A stamp collector pays more for a high-priced stamp than a stamp with a lower-priced stamp, and goes to dinner at a cheap restaurant instead of an expensive one. I would only buy a stamp to use it for me. That's me, and that's the way I go. And go to a more expensive restaurant to get better, not necessarily more expensive food. This is the base. Let me go to some symbols today. Denote the process of determining QA by this capital QA, this capital QA. This is the process of finding out. QA is the result of finding out. And that of determining PA by PA. Those who have studied linear algebra know that this is exactly an eigenvalue problem. Apply QA to the state, and then you get small QA. Apply that capital PA, and you get small PA. That was exactly what you do with the vectors in your linear algebra. Now, I, as a person, am a vector in the Hilbert space. I have an infinite number of preferences. So there's infinite variables. I'm a vector in a Hilbert space. That's psi I, for me. If I'm in a Q eigenstate, I've first been put into finding out how much I want. Then it's psi IQ, because I was asked a Q question. If I was asked a P question, vice versa, then I would be in a P state, psi and P. And so I could then get both of these, but you see, psi and P is not the same as psi and Q. I've gone into one state or the other, and they're not equal. So when I try to get both answers, then it won't remain the same. Look over here. What I'm saying is, first determine Q, now try to determine P. You'll get a different answer because now the state vector is that psi IQ, and when I try to determine P, I have to do an expansion of psi and P as vectors psi IQ and the rest, and then I get a different P. So I'm going to get PA, QA different from QA. It will depend on how we observe it. The obvious question then is, my state is psi I given this way, the coefficient times IQ with the sum of the squares of the coefficients equal to 1. Clearly, QP commutative bracket is not equal to 0. In quantum mechanics, this is IH cut delta AB over 2. H cut is the universal constant, Planck's constant over 2 pi, and this would then be the result. But here, quantum economics is going to differ totally from physics in a very big way. Because there's no universal constant H cut. It's going to vary person to person. And instead, QAPA equal to IH cut AB, depending on who is being asked, X, if I'm asked, X, who is being asked. And then it is going to depend on the time. When, what, so this is going to vary from person to person, that Y is unique. So person to person, X, and time to time, T. The lesson learned from my quantum economics is not the details of the formulae, but the shift of economic thinking from following classical mechanics. In his 1994 bestseller, Shadows of Mind, Logic Penrose proposed that the human brain uses quantum entanglement for thought. This was followed much later by Dynamical, who also argued that human thinking is inherently quantum. Two papers, 2006, 2015. And the claim is that there is the same quantum interference that Penrose has talked about for the person thinking, and here it is for the whole society thinking. There will be this interconnection, quantum-like interference of minds. So my mind influences Buddhism. Without Buddhism, you wouldn't be able to communicate anything just automatically. Physics somehow managed to do it. The work of Dynamical extends quantum entanglement from a single brain to the brains of a group of people. But even Penrose's idea was rejected by most neuroscientists. And for the group, it was surely rejected. However, by the psychological peer pressure, if we are not directly connected, but we are connected as being part of the same group, then peer pressure will develop. I talk to him, and he talks to him, he talks there, he talks to Diana, and the peer pressure develops over the whole group without direct interconnection. That would explain mob behavior much more easily. In fact, that is how people normally think that mob behavior is explained. So Kolenikov uses that mechanism in his later work to model cognitive behavior. This has led to one line of investigation. Finance separately lends itself to the use of the variation of all possible paths to a given final outcome. You know what you finally want, and so now all possible things that can lead to the final outcome. Now this is exactly what was done by Richard Feynman with his path integral formalism, using a Lagrangian integral exponential of the integral of the Lagrangian. And the Lagrangian is what you're also using in economics. And that is where you're minimizing the quantity. And then this will also give you a Feynman path integral. This was done by the Bangladeshi physicist Milad Bhatti, who then developed this and published. This is 2007, but he'd done the work earlier. I'm just quoting his book, which the paper was before that. It has been pointed out that quantum probability is the next simplest step after classical probability theory. It is normally just assume probability is probability is probability. That's not true. Probability in quantum theory is totally different from probability in the normal way of working. The difference essentially comes in from the difference in logic. The law of the excluded middle of Aristotle does not apply in quantum theory. When you go for the prisoner's dilemma, you have that there's no communication between the two. When you go to a quantum beam, there is. You get the half. But that isn't classically possible. In physics, we see it there. That's entanglement. This is what Kolenikov was wanting to do separately with just physical, which I would argue should have been looked at as peer pressure and not physical, but social. There's social entanglement, very obviously there is. We know that happens. So, quantum effects in economics were investigated independently 36 years after me. I had done that in before, as I said. But 36 years in what was called the order effect, which I was talking about, was proposed and validated by one time, which I had predicted at that time. And this is the same one proposed and then validated there. That's 2014. Of course, I assume they had no idea that the prediction was made in 1978. I presume they would have cited me if they had come across it. I can see very good reason why they hadn't come across it, because it was published in Pakistan Economic and Social Review. And who reads Pakistan Economic and Social Review? Following the same line of reasoning, but without any idea about the previous work, Wendt introduces quantum theory and problems of interpretation from a philosophical viewpoint and concludes that quantum theory is needed to discuss social behavior. Then, in 2018, David O'Reilly published a paper and then a book where he discovered my paper and cited it and explained what I had said. But he tried his way of looking at credit creation, which is slightly different. I won't have time to go into that. Notice that last part of the title of the book. I'm going to come later to that. Going back to my approach, one can average over the whole economy at any time and repeat the process several times. As such, we can expect a more or less diagonal HAB for a given society in a given era. More or less, not totally. Using the average diagonal sales for the economy, the analog economic uncertainty relationships are given here. Delta Q, delta P, that way. While economists like to justify their subjects using mechanical analogs, it is useful, I think, to teach physics students through their wallets. Actually, I'd say even economics students might find that being explained through their wallets will make sense more than anything else. Using the economics. For example, the dissipation of energy as heat in the conversion of one form of energy to another is like paying a money changer for converting one currency to another. This also demonstrates the second law of thermodynamics of entropy always increasing. Always the money changer has to live. He's not that coming anyhow. So, while teaching quantum mechanics, I used to explain the uncertainty principle as borrowing and returning energy, like one borrows and returns a loan of money. If it will take a long time, we have to do more for it. Going to quantum field theory, one has a vacuum not regarded as nothing there, but as energy getting created here and destroyed there, back and forth. Fluctuations all over. On average, there is nothing there. Just like money is gained or lost. But when I say on average, there is nothing, something here at any time, and different times, different things. If I look at the standard deviation, that's not zero. That's first. In field theory, energy is conserved if the canonical variables do not change with time, but will change if they do. In examples of gravitational waves in physics that have been in the news that vary in an oscillatory manner whole cosmology where there's expanding universe and energy density anywhere decreases. In economics, it changes as a matter of course. If the money is earning compound interest, P1 plus R to the T from your school days, the wealth actually increases exponentially, PE to the RT, your high school days, where R is the interest rate per unit time, and T is the time taken that the money is being invested in those units. The bank accounting time is discrete, but the growth is continuous. Obviously, the bank is making PE to the RT minus P times 1 plus R, so that's R squared over 2 plus R cubed over 3, where I'm taking T as a unit time. So, and then I can go raise it to the power of the number of units of time, get the answer there. The R is small, so it's R squared, small, R cubed, small. When it's that small added together, it can become very large. That's what the bank does. There's the process of credit creation. You're borrowing from the future. You say, this will get produced anyhow, so I'll take now because I need it to be able to generate the wealth which will come later. That's credit creation. You're going to pay off with the wealth generated in the meantime. You borrow and then you'll pay back. There should obviously be a limit to how much we can borrow from the future. At present, the world is borrowing so much that it is causing a collapse. Much like Pakistan is doing. So, in conclusion, much can be learned in physics and in economics by looking at the analogies between the two. David O'Reilly has been looking at it his way, I'm looking at it my way, and others in their way. I get to mention Shahid had said that the lesson we've learned is that the free market works. Is that? So does an atom bomb. Do we want an economic atomic? Let me go way back to that point where I mentioned Lenn's book. Money, Magic, and How to Dismantle a Financial Bomb. Quantum Economics for the Real World. I stress we have to question not the mathematics and its detail and so on. That's not where the problems might lie. Do we want an economic atomic bomb is a different question. I'm saying we need to rethink. The economy of our country is sinking. That's a pity. Our world is drowning. Why? Because we don't produce it and don't consume it. All ways of thinking are desperately needed now. Not 5 years in the future or 10 years in the future. We may not have 5 or 10 years. We need to start thinking today. We need to start thinking, as I say to my students, yesterday. Thank you.